In this video we're going to take a look at two examples from our vector unit. And the first one we're going to have two forces and we're going to find the resultant of them. And so we have the magnitude and direction of two forces are 30 pounds and 31 degrees, 70 pounds at 102 degrees, and these are acting upon an object. Alright, so the best way to start this is with a graph. So we're going to sketch a quick graph, and a lot of vector problems become a lot simpler if you take the time to graph them out. So the first one we have is at 31 degrees, and it's going something like this, and it is, let me shrink that up a little bit, because that's just a 30 pounder at 31 degrees. Alright. Then we have another vector. It's a little larger vector, okay, because it is a 70-pound vector at 102. And remember, the length is the magnitude. So this is going to be a longer vector. We're not drawing it perfectly to scale, but it helps to be close. And this is 102 degrees. All right. And now what we need to do is we need to find the component form of this. And we had a formula for that, and that's the magnitude times the cosine of 31 and the magnitude times the sine of 31, the sine of the angle. And if you forget that formula or why it is that way, then just keep in mind that all we're looking for here is we're looking for the x and y coordinates here of this terminal point here. So to find the x and y points, we get a little right triangle. We know the angle, we know the hypotenuse, so sine and cosine give us the x and y, and we end up here. This other vector, let's go ahead and call this, let's call this u, just so we can talk about it. And let's call this other one here v. Well, this is going to be 70 cosine of 102 and 70 sine 102. Okay, now this is just going to give us some decimal number here. And these are some decimal numbers. What we need to find is we need to find the resultant. Now the resultant is that line that goes in the middle here. And let's go ahead and graph that. If we were to take this u vector and copy it over like this, let's copy this u vector, we'll drag it up here. Okay, without making too much of a mess here. Okay. So if we were to copy this end to end, tail to end that is, and then we were to draw in the vector that connects these two, okay, that is our resultant. Call it R. And now we need to find the coordinates of that. Well, that just comes from adding. So we're going to add these two vectors. And so we get our resultant vector is just the sum of these two. And we're going to add it component wise. We get 70 cosine 102 plus 30 cosine 31. That'll, whatever that comes out to be, that will be our first component. Then we have 70 sine 102 plus 30 sine 31. Alright? And let's see what that comes out to be. And go into our calculator. This comes out to be 11.16 and 83.92. Actually, let's go a little bit more accurate here. 11.16 83.9212 and 83.9215. Alright, so there's our resultant vector. Now, all we need to do is find the magnitude and the angle of that vector. Okay, and so to find the magnitude of r, basically it's the Pythagorean theorem. So we got 11.1612 squared plus 83.9215 squared, all that square rooted, and that comes out to be approximately 84.66. Actually, we're going from the nearest tenth of degree, so we'll go to 84.7 degrees. No, I'm sorry, it's not the degree. We are finding the resultant force here. The magnitude, that is, 84.7 pounds. Okay? And now the direction, we can use the inverse tangent. And we have the inverse tangent of y over x, which would be 83.9215, all over 11.1612. And that gives us approximately 82.1 degrees. Alright, and there you have it. And our drawing kind of confirms all of that information a little bit. Drawing's not perfect, but if we do it carefully, yeah, looks like we're talking about the 82-degree range here. And the magnitude's going to be a little bit more than the 70 because the 30 is giving a little bit of movement towards the 70 direction there, a little bit of force. So there we have it. Let's try another one. In this problem, we have a box being pulled up a ramp. It's 100. We're pulling it with a 100-pound force. So let's go ahead and label as we go. So this is 100 pounds, and it's pulling up the rope. And the rope is at the ramp is at a 13-degree angle with the horizontal. So this is 13 degrees for theta. That's theta there. The rope forms a 32-degree angle with the horizontal. So this angle right here is going to be 32 minus 13, which is 19 degrees. Okay? So that's going to be useful there. Okay? Now we want to find the component form of the force vector. Now, to find the force vector, let's keep in mind, let's go back to the fact that this force vector is at 32 degrees with the horizontal, and we know we've got a magnitude of 100. Well, we can find the component forms by using our rule of the first component is 100 times the cosine of the angle, and the second component is 100 times the sine of the angle. Okay? And that comes out to be 84.80 and 52.99. Now I'm going to find the amount of work done on the box if it's pulled 28 feet along the ramp. Well, to find this, we're going to go back to this 19-degree angle here. And we have this force. Let me get a little. With this 100-pound force. Okay. We have the effective force going up here. And if we were to drop down or think about the projection here. Okay. If we were to kind of come down at 90 degrees off of this vector, okay, we get this projection force. And so we want to know, we know this angle here is 19. Okay. And actually, let's go ahead and, you know what, this we're pulling at 28 feet. Okay, and actually we got to think of these as separate vectors, because one's in feet, one's in degrees. All that really matters is this, our angle between it. And we have our formula. Work is the magnitude of the force vector times the magnitude of the direction vector times the cosine of the angle between them. Okay, and so the force is 100 pounds times the distance of 28 feet times the cosine of 19 degrees. And we can compute what that is approximately. And that is 2,647.5. And that is in foot-pounds. Okay. All right. And that is the work done pulling it up 28 feet. Okay. The angle between them is 19. We just multiply it using that formula, and there you have it. All right. And so that's how we find the magnitude and the component form and the work, all that good stuff, for a force that's pulling a box up a ramp. And this first one here gives us the magnitude and direction of the resultant. Keep in mind the resultant is what we get when we add the component form of the two vectors that are being acting upon the same object. So there you have it. Good luck.